Hey everybody, this is Larry. This is day 8 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Cherry Pickup 2. So I think I remember this one. To be honest, I messed up on this one during the contest because I misread. I think I misread what, because I do remember this one from the contest because I misread this during the contest and then I submitted because of the penalty, and I think I end up like I don't remember where I end up, but I think I would have been like a high score, or not a high score, but like I would have had a good score. But then I end up eating that 5 minutes of penalty and then doing it. And the reason why I had that wrong answer is because I looked at this particular diagram. I don't know why you can't highlight it. Okay, this particular diagram, and I thought that you can go. I thought you could go to the first row and then the second element, and or the last row, or the last column, or second to last column. So I kind of misunderstood this drawing, which they still haven't fixed, I suppose, instead of just starting literally at the corner. But that said, this is going to be a dynamic programming one. You can do it in, I think you could do it with top down. I mean, you should be able to do it top down. The only question is whether Leetcode is a little bit awkward and weird enough that it gives you a time limit exceeded. And then from that, it's just thinking about states. And for that, I recommend, just thinking about dynamic programming and just thinking about like working on a simpler dynamic programming problem per se, and then figuring out the states. This one is an extension of the grid thing. And we'll go over with my thought process a little bit and kind of thinking about the simplification. That's not a word. Talking about simplifying it. Yeah. So the way that I would think about it is actually, is this the one where I actually don't remember this one in detail. I just remember how I got the wrong answer, so that's good. Okay. So yeah, they stay in the same cell. So the key trick about this one is that if you simulate them at the same time, then you have the benefit of knowing, like if you simulate them at the same time going row to row, then you have a very easy way to check whether they overlap in the same path. Otherwise, it is a little bit trickier. So let's get started on that one, right? So then here we have a recursive function. I'm just going to go for now. Or maybe get cherries. And then you have x1, which is robot 1, x2, which is robot 2, and then R for the row. Maybe that's not consistent. I don't know. Yeah. Let's just say Y for the row, right? And then here we think about the base case. Of course, if we kick it off, we're just going to write return get cherries of from 0, and then the columns. How many columns are there, right? So rows is equal to the length of grid, and column is just length of the grid of the first row because there is a rectangular thing. So then here we just go from 0, c minus 1, and 0 is the y, right? So okay. So if y is equal to row, that's the base case, we can return 0, right? Because we're done pretty much. Otherwise, there are only a couple of ways we can do, right? So, yeah, I don't know if my other video is going to be better. So if this video is a little bit dubious, feel free to fast forward. I am doing this a little bit live, but also check out my other video that I did on this problem that I did during the contest. Can't believe it's that long ago, but I don't remember when I did it, but it was during a contest, so I don't know. Okay, so then now, let's see. Not gonna lie, because I have a little bit, I don't know, I think I'm allergic to something, and hopefully it's not COVID. So this video may be a little bit short, to be honest, because I have trouble talking. Also, but it is also like 30 degrees Celsius, is it even? Or not Celsius, 30 degrees Fahrenheit, or maybe even lower. I think it was 20 degrees Fahrenheit, which is, for those of you in Celsius, below 0. So my like ears are red and everything is just very cold outside. And I just got back. So that is my apologies. So if this is not a great explanation, check out my other video. I probably made more effort there, but okay. So then now we just have to enumerate the possibilities, right? So robot 1 can go down, like left, left down, down left, or sorry, left down, down, and down right, and so is x2, right? So now we can do maybe for dx1 is in range of -1, and then 2, it's a very awkward looking thing in for loop because it's an exclusive range, and then same for x2, and then now new x1 is equal to x1 plus, maybe we could do this way because it's a little bit easier. dx1, if nx of 1 is in between 0 and the number of columns, then we do this thing. So then we save a little bit on some iterations. Yeah, and then we just make sure that this is inside the bounds. And if this is so, best is equal to 0. That's the best number of cherries we can pick. Otherwise, best is equal to get cherries of new x1, new x2, and y plus 1, right? And then we return best. We didn't really pick up the cherries yet, but so we'll do that now. So now that we're at the cherries, our current score is equal to 0. If x1 is equal to x2, then we share at the same space because by definition they're the same y. Then we just add grid of x1y. Oops. Else, if they're different, then we add both the scores because we can afford it, right? So this way, because we're doing it at the same time, we reduce the space from r squared times c squared to r squared c squared, right? Oh, sorry, r squared c, right? And we'll go over that in a second, but yeah, but these are the number of cherries in those things, and I think that should be good enough, even though this would maybe time limit exceeded for a bigger case, but really, did I mess up the? Oh, I did mess up the thing. Okay, I confused the x and the y, so okay, but that should be okay. We have to make sure our bounds are right, but okay, let's actually start over. Because I usually do x for my rows, so this would be a little bit inconsistent if I do it this way. But now we do, y, and then now we do if x is equal to row. I messed up, sorry friends. But yeah, if y1 is equal to y2, then we do x y1. Otherwise, we add this. Oops. And then now we do dy. And now this actually makes sense. Also, my keyboard's a little sticky. I don't know why. Like, I guess I've been eating near the keyboard, but yeah, mistakes were made. So then now we have x plus 1 and y1 and y2, right? So these are all the possibilities. That's how I know that this works, is because we test every possibility, right? Oh, I forgot to add the score here. Score, okay. So yeah, okay, so we're wrong. Whoops. Dong. Did I mess something up? Guess we're okay. Oh, well, we kicked this off weird. So, though maybe it should still be the same. It's just we just swap y1 and y2. Though let's check it anyway. Huh. Okay, so why do we have 16? Man, I am not in shape today. Not gonna lie. But let's kind of at least print out, kind of see why we are the way we are. I think I solved this much quicker during the contest. Don't know what happened today, but okay. So from row 0 to 16, we should have 24. So this is 4 plus So ideally here we have 24, and at 1, 1, 2 is 12, but what's 1 and 0? Are we missing that example? Oh wait, no, it's here somewhere. 1, 0, 1 is 18. So this is already bigger than 16. So I know that definitely we have some weirdness here, right? Because that should go from here. Huh. Oh, whoops. I am just being really silly today. I just forgot the max function. Okay, wow. Yikes. Okay, so this looks good. And this looks good. I'm like halfway there. Sorry, friends. Today's video is a little bit sketchy, not gonna lie. But yeah, so this looks good, and we should be able to submit, except for what we need to do now is add memorization. And then here, as we always do, then we might have cache is equal to, and this is going to be a three-dimensional thing, which is a little bit tougher. Yeah, it is what it is. So here, let's think about what we want, right? So x can be from 0 to r, y1 can be from 0 to c, and y2 can be from 0 to c as well. So we actually want something that allow us to use, what we want is something like if has cache of x, y1, y2, return cache of x, y1, y2, right? Something like that. So then here we want the first Python matrix initialization is always a little bit awkward as well. So yeah, so first this is going to be this times c for the in range of c for range in r. I think this is right, but because it is very awkward, not gonna lie, right? But yeah. So this looks good. Is the timing okay? I'm not sure. So here right now, actually I'm relatively sure it gets cached, but just to kind of play along a little bit, we can extend this a little bit, and just to see whether, yeah, because this is exponential without the memorization, so it's kind of in theory easy to kind of get it to go out of bounds otherwise. Well, not out of bounds, but just like time limited if this is not so yeah, so given that this has, I don't know, 20, 30 items, and each of these would branch out like 9 times, this should be okay. So let's give it a submit. Apparently I've done it twice already. Actually don't remember the other two. So so yeah. So I would say it's been a year and change. I definitely am, I'm not gonna lie, I don't know, I don't feel great today, so this video is not great. I apologize for that, but it seems like I've done this video twice, so I'll have a link below. So my apologies, but as you can see, even Larry that is very suboptimal can, figure this out even with a lot of silliness and a lot of typos and a lot of mixing things up. But as long as you kind of, recognize the concepts, it's kind of easy to, or not easy, but it's doable to kind of repeat, even if it's a little bit slower. Yeah. So this one, like I said, yeah, as I said, I actually counted this like one row in before, and I got a wrong answer because, yeah, I didn't, yeah, I didn't do it that way. That was a little bit silly, and then I had to correct it during the contest. That was actually very sad during the contest, because I just like added the thing. No, actually, the way that I voted is a little bit awkward, so maybe that's my fault too. Where did I end up? What was my complaint? So yeah, so I ended up 26 on this contest, and if I did not have that 5-minute penalty, I would have been top 10. So that would have been really nice. So I guess that's what I vaguely remembered. But I guess 26 was not that bad. And to be honest, during this contest, even with the wrong answer, I think I saw faster than I did today. So I don't know, whatever, your mileage may vary. But yeah, let's go over the complexity real quick because I did not do that. But yeah, here, right? So the number of possible inputs is R times C, because this can be over to R, this could be C over to C. So technically you could do some magic to swap these two or whatever when y1 is less than, or y1 is greater than y2, and that'll half your things. But yeah, and for each input we do O of 9, I guess, which I know O of 9 is O of 1, but that's kind of to kind of illustrate these for loops, which is O of 1. So that means that for each input we do O of 1, and because there are these number of inputs, this is going to be R times C squared. And then yeah, for space this is also easier to see, which is because we have these matrices. Yeah, sorry, I'm having some trouble talking, so that's all I'm gonna have for today. Stay good, stay healthy, to good mental health. I'll see you later. I'll put a link on the other videos. My bad if you don't enjoy this video. I'll see you later. Contest is tomorrow. Have a great weekend. Good luck on the contests. Yeah, stay good. Bye bye.